Okay, so for today's video, we'll be discussing about topic alkene. So first thing first, we know that the type of reaction for alkene is electrophilic addition, and there are 5 reaction of electrophilic addition. So first, we must know that electrophilic addition is the breakdown of double bond to form 2 new single bond. For example, right here, so the double bond will break down and to form 2 new single bond. So for the first case, we have the H in the presence of catalyst. So the atom that will be added into the 2 new single bond is H and H. So this reaction is called hydrogenation. So for the second, we have Cl2 or Br2 in its solvent. In its solvent refer to H2Cl2. So in this case, will be added Br and also Br. So these 2 reaction is actually does not require Markovnikov, because the atom added is the same. And then moving on to the third, we have the Cl2, Br2 in water. So will be added Br and also OH. So in this case, we need to consider the Markovnikov rule. So when we consider Markovnikov rule, Br will be added to the carbon that has greater hydrogen atom. And this is called halogenation in water. So next, we have hydrogen halides, for example, HCl or HBr, and will be added H and also Br, and this also requires Markovnikov rule. So H will be added to the carbon that has a greater hydrogen atom. So lastly, we have alkene react with acidified water, so will be added H and also OH. So H will be added to the carbon that has the greater hydrogen. So this is required Markovnikov rule. This is required Markovnikov rule if the alkene given to us is unsymmetrical. If the alkene given to us is symmetrical, so we don't need to follow the Markovnikov rule. So moving on to the questions. So in this question, the reactant is A, but we don't be given the A. So the only clue we have here is by looking at this compound. So we know that this compound was originally an alkene. So we know that Br is being added here, Br and Br. So to know the reactant, we just need to reverse back the process by removing the 2 atoms of Br. So the reactant will be CH3, CH3, C, H. So since we move these 2 Br over here, so will be added another bond. So they are double bond there. So this compound IP name is 2-methyl propene. And then the reagent is, since we are added Br, 2 Br, so the reagent will be this one. So since our product is Br2, so our reagent will be Br2, CH2, Cl2. So moving on, these 2-methyl propene react with excess oxygen. So we know that when there are excess, the combustion occur completely. So there are complete combustion occur. So this 2-methyl propane will be oxidized completely and form CO2 and H2O. Moving on, we have this 2-methyl propene react with Br2 in aqueous. So we know that this Br2 is mixed with water. So looking back at our electrophilic addition, we have this one, Cl2 or Br2 in water. So we'll be added Br and also OH. Br and also OH. So since our reactant is not symmetrical, so we need to consider the Markovnikov rule. So break down the double bond to form 2 new single bond. So Br will be added to the carbon that has most hydrogen atom. So OH will be added here. So moving on, we have this 2-methyl propene undergoes some reaction and it produces this one. So this is our clue. This is a brown precipitate. So we know that this 2-methyl propene is actually undergoes Bayes test. So when there is Bayes test, the addition is OH and OH. So we don't need to consider Markovnikov rule since the added molecule is the same. So break down the double bond. And form 2 new single bond. So OH will be added here. So lastly, we have this one from G to A. So from G to A, we know that this is actually a preparation of alkene. And when the reagent is concentrated H3PO4, 180 degrees Celsius, we know that the original compound was alcohol. So this alcohol undergo dehydration. So we just need to reverse back the process. And we will added H and OH over here. So this compound undergo dehydration, as I said earlier. So H2O, water will be removed. So when water will be removed, there are the presence of a bond over here. So it forms a double bond. So this is how our product is formed, or alkene is formed. So that's it for this video. Thank you for watching.